Okay, so yesterday we were talking about some past paper questions, and this was the first past paper question. I hope that you guys were able to understand this one. Okay, right. So basically we were discussing trigonometric equations, and it's just an equation that has a trigonometric function in it, right? So in this trigonometric equation, we had tan and sine. Always remember, end goal is to get an equation that has one trigonometric equation only. So you need to simplify, 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 simplify as much as you can. And once you reach equations or equation that has one trigonometric equation, you can directly either consider the graph that we have not discussed yet, but I just made the graph with it just so you guys know, or you can consider quadrants. Okay, depends. If sine theta, cos theta, tan theta is equal to 0, if it's equal to 0, just think about the graph. If it is equal to something positive or negative, think about the quadrants. Okay, and then we know we need to make sure that our answer lies within the range and all of that. Okay, all right, let's talk about the next part of the question. Okay, now this is basically this, that you need to prove this identity, right? You need to show that the left hand side is equal to right hand side. We won't do this for now because this is something we need to talk about, a few basic identities, and then we would be able to do it. We will talk about the next part of this question. Here it is. Okay, so both the parts are linked, and it says hence. So obviously if there's hence, it means we will be using the previous part as in the information given in the previous part, only that much information. Okay, 1 second, let's just read the question. Okay, it says solve the equation 1 minus 2 sine square theta divided by 1 minus sine square theta equals 2 tan 4 theta. Okay, since it says hence, the only part where I can use the previous part is that instead of this 2 tan 4 theta, I can just write this part, right? Because this thing is equal to this thing. So I can certainly write down 1 minus tan squared theta instead of this, okay? So I can rewrite my equation as 1 minus 2 sine square theta divided by 1 minus sine square theta equals, instead of this 2 tan to the power 4 theta, I am going to write down whatever I had in the previous part. And what made me do this? This hence made me do this. It says hence. So hence means that you need to use something in the previous part, and the only information in the previous part was this, that instead of writing down 2 tan 4, I can write it down as 1 minus, 1 second. Let me write this part down first. So this is basically 2 tan power 4 theta. Okay, this is the question, right? It says hence solve the equation. Hence means I need to use the previous part. Now when I look at it directly, what do I get to see? I get to see the fact that I have a variety of trigonometric functions, right? I have sine and tan, but ideally, if I just have one trigonometric function, that would have been just perfect, right? That would be just perfect. So how do I achieve that thing? Okay, what I know is, let me admit the student. Okay, I know that it is 1 minus 2 sine square theta divided by 1 minus sine square theta. Assalamu alaikum, Wali. Can you hear me?
Walaikum assalam. Yes, ma'am, I can hear you.
Okay, all right. So we are talking about some past paper questions, okay? About trigonometric equations.
Okay, ma'am.
All right, okay, perfect. So basically, in this part, what's happening? We were asked to solve this equation, and the issue is that sine and tan are two different trigonometric functions. I can do some simplification and make these two trigonometric functions one trigonometric function, but it is just a 3-mark question. So this much working and all of that is not required, okay? Hence means I need to use the previous part. So if I go to the previous part, it says this thing that we do have in the second part, this thing right here is basically equal to this thing. So it's equal to 1 minus tan square theta. So I can rewrite this thing as 1 minus tan square theta is equal to 2 tan to the power 4 theta. Now things look simple. Now I only have one trigonometric function, and that is tan. Okay, so I can do some simplification. So we used hence in order to get rid of this part, and I have just taken the right side of the identity I had in the first part, and I've written that. Okay, next let's just do some simplification. So it would become 2 tan to the power 4 plus 1 minus tan to the power square theta equals 0. Okay. Finally, I can write it as 2 tan to the power 4 theta plus tan square theta minus 1 equals 0. Okay. Now at this point, you can say that if I write this tan theta in terms of some other variable, if I write it as x, I would be able to simplify this. We know how to simplify such equations. We have studied that while studying the quadratic equations. You guys were able to identify that we had some equations which initially were not quadratic, but we were able to convert them to quadratic equations. How? So the rule was that if this number is double of this number, we used to make a substitution over here that y is equal to x squared. And using this, I can write this thing as 2x squared, 2y squared plus y minus 1 equals 0. Now it's very simple. It's just a direct quadratic equation. You need to just quickly think about the quadratic factors, or you can directly just tell me the value of y's. Yes.
Yes, why don't you just directly do that? Tan square theta
Yes,
is equal
we
to.
can. Yes, we can also do that. That's also fine. We can also do that, obviously. That's also fine. I just did this for those who are a bit uncomfortable with, who have just started looking at trigonometric equations for the first time, for those students, okay? But you can obviously do it that way as well. That is the same. It means the same.
Okay.
Okay, so the two quadratic factors would be, it would be 2y squared plus 2y minus y minus 1 equals 0. So I will take 2 and y common, y plus 1 minus 1 common, y plus 1 equals 0. And this would give me 2y minus 1, y plus 1 equals 0. So y is equal to 1 by 2 and y is equal to minus 1. Okay. At this point, you can think about it this way as well, that this x squared was basically your tan squared theta. So tan squared theta is equal to 1 by 2, and tan squared theta cannot be equal to -1, but let's just write it down, okay? So what has happened in this question, let's just quickly go through it once again. This was a trigonometric equation that you guys were asked to solve, and we don't know how to solve such trigonometric equations where we have two different trigonometric functions. So it had the word hence in it. We used the previous part, and I've just skipped this thing, and instead of this I wrote 1 minus tan squared theta. From where exactly I got this? I got this from the previous part of the same question, okay? Then I had tan. Some students are not very comfortable with trigonometric equations, trigonometric functions. So I've just written x squared and I just made some substitutions. You could have done directly as well. That was equally good, equally fine. And finally, this is what we got. So this equation is fine, but tan squared theta cannot be equal to something negative, right? So for this part, we are just going to consider the first equation, this one, because that won't be correct. When you will take under root on the other side, this would turn out to be wrong. So no solution from this, and you would only get solution from the first equation. And now what exactly that solution would be? Okay, so for that, think about it this way. Tan theta is equal to, I will take under root, and this would become plus minus 0.5. Okay, now this is something important. Okay, if you guys were not able to understand anything in the past, just forget that. This part is very, very important. Okay, so finally, after doing some simplification, we got tan equals positive root 0.5 and negative root 0.5. Okay, now you need to think about the quadrants. Okay, now this one is basically my first quadrant. Then we have the second one. Then here is the third one. And then this is the fourth quadrant. Okay. All right. So first of all, let's just do simple step. Okay. Make sure that your calculators are in degrees mode because this interval again is in degrees. Okay. Then just do tan inverse of 0.5. And that would give
Miss,
you, yes.
Miss, why can't we use the value negative?
Yeah, we will use that. For now, I'm just talking about the first value. Just think about it as two, you are right. Think about it as two equations. We will talk about that, okay? Let's just consider this one first. Wait one second. I'm just considering tan theta equals root 0.5. Okay, this is the first one and then this is the second one. You're right. We will talk about both of them, okay? We will see what would be happening with this case, okay? So for the first one, I'm just talking about the first one. For the first one, I got 35.26. 35.26. The 35.26 is my alpha basically. Okay, now tan is equal to positive root 0.5. It's positive. When is tan positive? Tan is positive in the first quadrant because all are positive. Okay, and then it was add sugar. Sugar was sign. Sign is positive in the second quadrant, so we would not be considering that. 2 is basically tan is again positive. So it means now it is the third quadrant. Okay, and for the third quadrant, how do we find angle? For the third quadrant, it is going to be
180 plus.
Yes. This alpha is going to remain same, 35.26 degrees. And for the third quadrant, we start off from here and we go all the way down there. So it is going to be 180 plus whatever alpha we had, that is 35.26. So what would be the value? It would be greater than 180, but let's just write it down for the sake of completeness. Okay. So for the first quadrant, I got 35.26 degrees. For the third quadrant, I am getting 215.26 degrees, okay? If you look at the interval, it's only till 180 degrees. Your value must be between 0 and 180. So we cannot consider the second solution. We cannot consider this solution, okay? So far we are just done with the first equation. Now I'll wait for 2 to 3 minutes. I want you guys to consider this one and tell me whatever you're getting as your answers. I'm here, but just think about it first and then reply. Okay, just message me directly, don't say anything loudly, and obviously wrong answers are completely acceptable. That's not an issue. Please keep your mics muted. Someone's mic is unmuted. Yes, just try doing it. I won't mind any wrong answer. I just want you guys to give it a try, okay? You need to consider the second equation, basically, this one. So tan theta is negative, okay? Just see when exactly is tan theta negative. This is cos. Cos is positive in the fourth quadrant. Anyone who's done?
Yes, miss.
Okay, I didn't get your answer. So what did you get as a theta? Theta from the second equation?
Miss 145.
Very good. Excellent. Well done. Okay. Okay. So for the second equation, it was tan theta equals negative root 0.5. It's negative now. Okay. First of all, let's go and encircle our required coordinates. When is tan negative? In the first quadrant? No, because in the first quadrant, all the trigonometric ratios are positive. In the second quadrant, yes, because in the second quadrant, only sine is positive, cos and tan are negative. So this would be the quadrant I would be interested in. Then is it the third quadrant? No, it's not the third quadrant because tan is positive in the third quadrant, and then it is the fourth quadrant. Initially, when you are looking for values, forget about your interval, right? Just forget your interval because this is the beginning, okay? So now it is the second quadrant. For the second quadrant, this is how I find the angle. It's basically 180 minus alpha. So we need to find alpha. This is basically my alpha. And what is alpha? Just 2 tan inverse root 0.5. It is negative, but when you will use negative root 0.5, that would just give you negative 35.5, right? So that is also fine. We also have a way of converting it to positive and then using it, but just like Rafe said, you can directly make it positive and then find its inverse. So when we will do tan inverse root 0.5, we would get the same thing. It is 35.26. And for the second quadrant, we are going to get 144.7. This 144.7 is basically 180 minus alpha. Okay, so this is what I got. This is going to be the third answer. Basically, second was not considered. 144.7. And for the fourth answer, now I need to find the angle in the fourth quadrant. This is the line. Again, the basic angle is same. It's 35.26. And how do we find angle in the fourth quadrant? So I will start off from here. I'll go all the way like this, like this, like this, and I need to stop here. Okay. So if I talk about angles in a circle, that's 360. I'll just take 35.26 out, and this is going to give me 360 minus 35.26. And that is 325. Okay. The fourth one is 325 degrees. Now, what was the issue with this one? The issue was that our interval is only valid between 0 and 180 degrees. Any theta that is outside 0 and 180 degrees would not be considered. Okay, so even this cannot be considered. So the final answer is going to be 35.26 and 144.7 degrees. This is going to be the final answer. Okay. Now, those who were not able to understand something can either just type or let me know directly, just so I can explain this question again. I would not mind doing that. Okay. Yes. Anything, any other thing, Rafi, that is coming to your mind? Any other method?
No, miss.
Okay. All right. So any other thing, Wali, would you like to ask something?
No, ma'am. I understood.
Okay. And Munja, any questions?
No, as you clarified, misunderstanding at first, but I think.
Okay, so
No.
it's fine now.
Yes, yeah.
Okay, perfect. Okay, we did not do the first part of this question because I would talk about about some identities that you can think about as helping identities, and then we will see how to solve the first part. Okay, let's talk about another question. Okay, now this question is not directly related to whatever we're studying. It had a trigonometric function and it has something that we have already discussed in the past. Okay, so let's talk about this part. Okay, it says the curve y equals sine 2x minus 5x is reflected in the y-axis. Okay, so it is about transformation, and then stretched by a scale factor of 1/3 in the x direction. Write down the equation of the transformed curve. Okay. All right. So first of all, we need to understand the fact that it is reflected in the y-axis. So what was happening for reflections in y-axis or x-axis? Yes.
Miss, can you show the paper of this specific question?
Wait 1 second. Yes, this one. This is a separate part, and for the previous question was from some other part. Just note this down and then I'll show you the previous part as well.
Previous part was from 11, right? 11, 18, 21.
Yes.
Okay, miss.
Okay. Right. Can anyone tell me what used to happen in case of reflections in x-axis and y-axis? We used to have only a negative sign, right? when there were reflections in the x-axis, I used to multiply negative with all the x's. And when it was a reflection in the y-axis, I would be multiplying a negative sign with this entire thing. With whatever I have as y, I would just multiply negative with that, okay? So because of this reflection in y-axis, I am going to write it as, this would become, this is sine of 2x minus 5x. This is what I initially had. I would just multiply negative with it, and this is going to give me negative sine 2x plus 5x. Okay, so this is how the equation would be transformed once the curve has reflected. Okay, the next part says then stretched by the scale factor of 1/3 in the x direction. So if you guys remember, whenever we had f of ax, what used to happen? This used to be a stretch by a stretch factor of 1/a, right? Do you guys remember? Actually, when number was being multiplied with x, our shape was not stretching. It did not look like a stretch, right? It was not stretching. So this was basically that case. Here we have ax is being multiplied with x, but the stretch factor used to be 1/a. Okay, so I am going to multiply this 3 with x because I have 1/3 as my stretch factor. So this would mean that a is equal to 3. So I would get minus sine 2, and then with x I'll multiply 3 plus 5, and then again with x I'll multiply 3, and upon simplification I would get the final equation is going to be minus sine 6x plus 15x. This is going to be your answer. Okay, let me explain this again because this is something that you guys must have forgotten by now. This is about the transformations of functions. We know we have stretch, we have reflection, we have like you guys have studied enlargement as well in O levels, right? We have different transformations. Then we had rotation as well, but that was in O levels. What was happening in case of reflection? If it was in the x-axis, we were multiplying a negative sign with x. If it was in the y-axis, we were multiplying the negative sign with whatever you had as y, right? So this is what we had as y. I've just multiplied negative sign, and this is what I got. So far, I was just able to find the equation of the transformed curve that was only reflected in the y-axis, but we are not done yet. Once this curve was reflected in the y-axis, after that it was stretched by a stretch factor of 1/3. This is important. Just think about it. Just recall at this point that it was stretched in the x direction. Things used to be opposite. This 1/3 would not actually stretch your curve. It would actually squeeze your curve, right? Your curve would become smaller. And this, when this used to happen, we used to have f of ax basically, right? So a is being multiplied with x. A was being multiplied with x in the past, and our shape used to squeeze instead of stretching. This is what you need to understand. So it's 1/3. The stretch factor is 1/a. This means that a is 3. So this means that I would be multiplying a with x. That was 3 in our case. Okay, so this was x. Instead of this x, I wrote 3x. Instead of this x, I wrote 3x. And upon simplification, this is going to be the final equation of the transformed curve. Yes, now tell me very, very honestly if you guys have any confusions, anything that you were not able to understand at this point.
No, miss, everything's clear. Miss, can you tell which question number this is? From that
Okay,
specific.
yes. This is basically the second question.
Okay, miss.
Yes. Wali and Munja, anything that you would like to ask?
Can you check my message?
Yes, sure. 1 second. Is
I
it on
sent you a question.
on WhatsApp?
No,
Or?
it's here. It's right here.
Acha, okay, I'll tell you. Just send that message 1 second. I will just message you. I have basically 2 accounts over here. So I will message you and then reply to that message, okay? Okay, just reply to this message and I will just wait. Let me see if we have, yeah, okay, this was the last part. Okay, will you just reply to this message, okay? I've sent to another account.
Ma'am, I've replied.
Achha, I did not get you. Just can you message me
I
directly
just
on
asked it
WhatsApp?
here, yes, ma'am. For stretch, it's 1 over a. So what will it be for squeeze?
Okay, I'll tell you. 1 second, 1 second, 1 second. We only say stretch, okay? We only say stretch. We don't say squeeze. The word is stretch only. But when the stretch factor is 2, उस time पे you would get to see a genuine stretch, right? This again is stretch. Like this again is stretch. But the stretch factor is less than 1, right? It's 1/3. So this is being called stretch. But actually in simple language, I would call it a squeeze. Like it's not stretching. It is stretching, but by a stretch factor of 1/3. So wo jo actual shape thi, that would basically reduce 3 times, right? This is still called a stretch. I won't call it a squeeze. This is stretch. Even if it is being stretched genuinely or if it is being squeezed, we call it stretch. The only thing we do is we just add a stretch factor or a scale factor. Whenever your scale factor is greater than 1, in that case, your shape is actually being stretched. But whenever it is less than 1, like it's 1 by, whenever it's a fraction, it is not being stretched actually, although we write it that way. But if you look at the actual graphs, you would get to see a squeeze rather than a stretch, okay?
Yes,
This
ma'am,
is
got
what
it. But my question is, what if it was like greater than 1?
okay,
Then would
okay,
we,
yes. I'll tell you. Okay, very
like,
good.
if it was 3, scale
Yes,
factor 3, then what would we do?
very good. Okay, I'll tell you. So imagine that this was the question, okay? So what would be happening? Again, look at it this way. Look at it this way. Same logic is being used here again, okay? It's f of ax, okay? And then the stretch is by a stretch factor of 1 by a. Now think about your a. You know that your stretch factor is equal to 3. What would be your a? You can just make a the subject. I'll take a on the
Ma'am,
other side. I'll
it will
take
be 1/3.
Yes, very good. A would be 1/3. When A would be 1/3, I would be having
So you
1 by
will,
3 here. Yes, and this would
yes,
basically
ma'am,
be,
got it.
yes, very
Thank
good.
you.
It would be 1/3. Okay, perfect. Okay, so this was basically something different in case of X. Okay, Munja, do you have any question?
No, ma'am.
Okay. All right. Okay. So I think that is it for these questions. Now I am going to stop the recording. We'll talk about it later on. I will talk about some other stuff